Alright, first things first, we're going to draw a cross section here. So a little slice of water. And that shape is a rectangular prism. So it's going to be, any prism is the area of the base, and in this case it's a rectangle, times the height, and we'll work this out. Now, we're going to have to do a little bit of work here because the base and the height of this rectangle are not always the same. So what I'm going to do is I'm going to call this height x, and then I'm going to call this length all the way across here y. And I'm going to set up a proportion because I don't want it to be in two variables. I want to figure out what the length, because I need the area of the rectangle, and the area is the length times the width. Now the length is changing, right, depending on how long it is. The width, this part here, that 6 is always going to be the same. But what I'm going to need to do is find this length here in terms of x. So to relate them, I've got some similar triangles going on. The bigger most triangle has a height of 3 and a width of 4, and my cross-sectional triangle has a height of x and a width of y. So if I solve for y, I get that y is 4/3 of x. Just do a little bit of cross multiplication. 3y equals 4x. Y is 4/3 of x. So the area of my rectangle is the length times the width. So the 4/3 x times the width, which is always 6, times the height of my little cross section, which is just a tiny change in x. So cleaning this up, this is 24 divided by 3 is 8x dx. Wonderful. Got the volume of a cross section. Now for the work, I figured out this formula in a LiveScribe video. This is the formula you use for work done pumping water when you're dealing with newtons, meters, and kilograms. So we'll take this 9810. Some books will just use 9800. This one's a little bit more specific. The volume of the ith slice is 8x dx. And then the distance traveled by the ith slice, well, to pump this cross-section out of the tank, it has to travel this much, right? So if it has to travel this much, that's not x. This is x. And it's not 3. The whole thing is 3. It's 3, take away that x. So the distance is 3 minus x. And now, where does your water start and where does it stop? Well, if this is x, my water starts at 0 and goes all the way up. They said the thing was 2 feet full to begin with, so 0 to 2. And that's that. Now in other videos I've shown how you could use a different version of x. You could start x at the top, and you could do that for this one here. It's just going to make the proportions slightly nastier, but it totally works. You could start the x at the top. I don't think I'm going to do it now, but you can play that you have some flexibility. But I didn't tell you an answer. If you plug this in on your calculator, you will get 261,600, and that is in joules. And that's that.